Okay, so now we're going to start to get more into depth of kind of how to conduct these experiments and what we can know about them. So to start that, we have to obviously understand some language that we're going to see while we talk about or set up experiments. So, an experiment is a statistical study in which we actually do something. We're going to call that a treatment to people, animals, or objects. Those will be referred to as experimental units to observe the response. Here is the basic vocabulary of experiments. Okay, so the treatment is the actual, quote unquote, experiment that you're going to be doing. So, what you're looking to change or what you're looking to see if there is a change, if something happens, you're actually going to want to impose some kind of experiment or some kind of treatment. The experimental units are the smallest collection of individuals to which the treatments are being applied. So those could be people, places, people, objects, or animals. When the units are human beings, we often call them subjects. Okay, so probably the best way to learn the language of experiments is to actually practice using it. So let's take a look at, a quick example and kind of identify some of these things. So researchers at the University of North Carolina were concerned about the increasing dropout rate in the state's high schools, especially for low-income students. Surveys of recent dropouts revealed that many of these students had started to lose interest during middle school. They said they saw little connection between what they were studying in school and their future plans. To change this perception, researchers developed a program called Career Start. The big idea of the program is that teachers show students how the topics they learn get used in specific careers. To test the effectiveness of Career Start, the researchers recruited 14 middle schools in Forsyth County to participate in an experiment. 7 of the schools determined at random used Career Start along with the district's standard curriculum. Researchers followed both groups of students for several years, collecting data on students' attendance, behavior, standardized test scores, level of engagement in school, and whether or not the students graduated from high school. The results were that students at schools that used Career Starts generally had better attendance and fewer discipline problems, earned higher test scores, reported greater engagement in their classes, and were more likely to graduate. Now we're going to identify the experimental units, the explanatory and response variables, as well as the treatments that were in the Career Start experiment. So the experimental units is going to be the 14 middle schools in Forsyth County that they selected. The explanatory variable is going to be whether to use the Career Start program with its students. The response variable is those test scores, attendance, behavior, student engagement, and graduation, right? Were those things responding to the explanatory variables? Okay, same as what we saw in Unit 2. And then the 2 treatments. So the standard middle school curriculum as opposed to the standard middle school curriculum plus the Career Start. Okay. So the previous example, or this example, illustrates the big advantage of experiments over observational studies. Experiments can actually give good evidence for causation. So in an experiment, we study the effects of the specific treatments we are interested in while trying to control for the effects of other variables. So, for example, the students in all the 14 schools followed this standard curriculum. To ensure that the 2 groups of the schools were as similar as possible before the treatments were administered, researchers would probably let chance decide which 7 of those schools would have used the Career Start. the only systematic difference between the schools was the educational treatment. So when the students from the Career Start schools did much better, researchers were able to actually conclude that the program did make a difference. So sometimes the explanatory variables in an experiment can be called factors. So many experiments study the joint effects of several factors. In an experiment, each treatment is formed by combining specific value. Often that'll be called a level, and each of those factors would be called would be probable in a multi-factor experiment. Okay, so just an example of a multi-factor experiment real quickly. Okay, so what are the effects of repeated exposure to advertising message? The answer may depend on both the length of the ad as well as how often it is repeated. An experiment investigated this question using 120 undergraduate students who volunteered to participate. All students viewed a 40-minute television program that included ads for a digital camera. Some subjects saw a 30-second commercial, others saw a 90-second version. The commercial was shown either 1, 3, or 5 times during the program. After viewing, all the subjects answered questions about their recall of the ad, their attitude toward the camera, and their intention to purchase it. Okay, so for the advertising study, let's identify the experimental units or subjects, explanatory and response variables, as well as the treatment. So the same thing as the last question, only this time you're going to see that it's a multi-factor experiment because you have quite a few different things going on here. Okay, so subjects are the 120 undergraduate students who were watching these ads. Okay. The explanatory variable, there's 2 of them. There's the length of the commercial, but then there's also the number of repetitions. So there was the 30-second commercial and the 90-second commercial. And then they also showed it to them 1, 3, or 5 times during the program. And then the response variables, okay, there's 3 of those. So they can measure of subjects' recall of the ad, okay, then their attitudes about the digital camera, and also whether they intend to purchase it, okay. And then there were 2 treatments, right? Because there were the 2 lengths, so the lengths, and then also the 3 repetitions. There's actually 6 combinations of treatments that can happen here, right? So if you think about it, right? The one treatment was 30 seconds 1 time. The second treatment could have been 30 seconds 3 times, then 30 seconds 5 times, 90 seconds 1 time, 90 seconds 3 times, and so on. Okay, so this example would show how experiments allow us to study the combined effect of actually several factors, not just one. So the interaction of several factors can produce effects that could not be predicted from looking at the effect of each factor alone. So perhaps longer commercials increase interest in a product, and more commercials also increase interest. But if we both make a commercial longer and show it more often, viewers get annoyed and their interest in the product drops. So the 2-factor experiment in TV advertising example will help find out that. Okay, so let's call this quits on this video.